Hello, everyone. My name is Tony Jolly. I'm a technical assistant here at RAECO Rents. If you've ever called our direct line, we've probably had a few conversations. I want to thank you all for taking the time out of your busy schedules to join us today for our webinar on the basics and benefits of sound and noise. Our presenter today is Andy Bragg with SKC, and during this webinar, he will cover some basic terms and definitions, basic training on field calibrations and conducting a survey, the benefits of today's technology, and towards the end, we will cover any questions that you guys have that you can throw in the chat box. Andy Bragg is the Director of Sales for SKC, and he has been with SKC for a little over 7 years and has been in the industrial hygiene and instrumentation sales arena for about 32 years now. He is a certified occupational hearing conservationist through CAOHC. Because of the large numbers of attendees, we will be muting the phone lines. If you have any questions, like I said before, you can throw it in the chat box, and we will try to answer as many as we can as long as time permits us. We will be sending out a certificate of attendance after the webinar, and we will also be posting the recording and slides on our website on our training center page. Welcome, Andy, and the floor is yours.
Thank you very much. I appreciate it. So, as Tony said, let me see if I can get my slides to change for me. As Tony said, my name is Andy Bragg, and I'm with SKC, and I really appreciate everybody joining. I'm excited about this. I'm going to try to squeeze about 2 hours of information into about 45 minutes. So I apologize if I go quickly, but please write down your questions or put them in the chat so that we can answer them when we get to the end. I'm trying to go a little quickly just so we make sure and have time for those questions. I want to say up front, I don't want to assume anybody's level of knowledge, so I'm going to cover some pretty basic stuff with regards to noise, and hopefully everybody will be able to learn a little bit as we go along. But I'm also going to save some time so that at the end we can kind of walk through the operation of the NoiseChek noise dosimeter for everyone that has rented it or is planning on renting it in the future. So the agenda, real quick, is why do we care? Why do we even care about noise? So I'll spend a little bit of time talking about that and covering that, and then go into some basic sound explanation. Are we talking about sound or are we talking about noise? Then cover some basic regulation information. This is normally something that in a noise seminar we would probably spend 30 to 45 minutes on, but we'll at least kind of glaze over it a little bit to give some exposure. So hopefully you can absorb some now and then maybe absorb a little bit more later. And then some basic instrumentation explanation, the difference between noise dosimeters, sound level meters. And then do some NoiseChek training as well. So then as far as my objectives, the introduction to hearing conservation, if you're not very versed on hearing conservation, talk a little bit about regulations and make sure that you get some of those points topics, and explain sound pressure level, frequency, and respective units of measure to those things, because a lot of times that can be confusing because it's not like gas detection or anything else. The units of measure are different. But my main objective is that you grasp the 6 key terms of dosimetry studies. If you know these, it's kind of half the battle, as I say there on the slide. It really is half the battle. Most of the problem and the intimidation that people get from doing noise studies is they're not comfortable with the verbiage. And once you get that verbiage down and you understand a little bit more, it starts becoming a little bit easier. And of course, my last objective is just to make sure that you're comfortable using a dosimeter so that you can conduct a noise survey if you need to. But first, we'll go to the why. Why do we measure sound or even care about potential hazards and noise levels? And I like to, in a class, in person especially, get some feedback. And there really isn't any wrong answer. Everybody has good ideas as to why we measure sound, as far as, protecting the hearing, because OSHA says we have to, or MSHA says we have to, or depending on what you're doing. And there really isn't any wrong answers. But for me personally, the main reason is, as Tony said, I'm CAOHC certified through the Council for Accreditation in Occupational Hearing Conservation. And so what that means is my main goal is hearing conservation. I want to make sure that people understand the value of your hearing and why it's so important. And that sounds kind of silly, especially if I have industrial hygienists on the call that have been doing this for a long time. It seems like common sense. But if you are an industrial hygienist and you've done noise surveys before, you also know that it's really hard to convince people sometimes, especially if they're 21 to 25 years old. They're not really worried about losing their hearing, and it's hard to convince them that they need to do something about it now. And so that's always a big push for me, is to try to make sure and convince young people that it is important. So a question I like to ask is, if you had to choose between losing your hearing or losing your eyesight, which one would you choose? And if you really think about that for a minute, I think most people would say they would rather lose their hearing rather than their eyesight. So it is a tough question to ask, but the more you think about it and the more we discuss this, I would guess that it will probably change, because if you lose your hearing, you no longer have contact with what's going on in the area. If you lose your eyesight, which would also be difficult, of course, you can hear what's going on. You can still interact with people. You can still have some comfort as to what's going on. So think about that as we discuss this, and I would challenge you sometime to find a set of earplugs that works really well, or some earmuffs, and wear them all day. At first it'd be kind of funny, you know, kind of a joke that you can't hear things, but leave them on all day. And by the end of the day, I assure you that you'll be very frustrated because you can't hear the things going on in your home or wherever you may be. So first, let's talk about the human ear. And this is the ear is a marvel to me. And the more you study it, it's miraculous how it works, because you hear my voice and other people on this call hear my voice and it sounds the same, or you hear a piano or a guitar and it sounds the same. What's amazing to me is you're not actually hearing that item. You're not hearing my voice. You're hearing sound waves that have been conducted into a signal into your brain that can be heard. And the way the ear works is pretty amazing. So I'm going to go through the three main parts of the ear very quickly, but I challenge you, if you have time, to look on the internet sometime. There's some really cool animations on how the human ear works, and it'll explain a little bit more about why. I know it's kind of corny, but I really do believe it's miraculous how it works. So the first part is the outer ear, and the outer ear, as you can see, kind of works like a funnel. And if you think about a funnel and you turn it sideways to this diagram, it kind of looks like a funnel. And the whole job of the outer ear, and the pinna is the part that you actually see on the outside of your ear, is to funnel all noise into the ear canal. And I'll replay that real quick just so you can kind of visualize. All this noise is coming from outside the ear, but it kind of gets funneled into the ear and goes down the ear canal. And that's very important. Seems simple, but it's very important. People ask me a lot of times if you do ear piercings and things like that, or you know, to your ear, does that cause any problems? And the answer is it really doesn't. We've all noticed, you know, some people have large ears, some people have small ears, some people have oddly shaped ears, longer earlobes, whatever the case may be. So the ear amazingly works very well in different shapes, and unless you decide you want to put 20 or 30 earrings on one ear, you shouldn't have any issues caused by piercings. I would challenge you as much as possible not to try to clean your ear, whether it be with a Q-tip or anything else, because surprisingly what happens is when you do clean your ear with a Q-tip, your ear produces more wax, and you kind of counterproductive in what you're trying to do. So just let it clean itself naturally if you can. You also don't want to damage your eardrum, or the tympanic membrane is what it's called. You also don't want to damage that by doing that. So just try to resist that when possible, but I know there are issues where you feel like you have to, but try to resist it when you can. So then we move to the middle ear. And the middle ear is pretty amazing. There are three of the smallest bones in the body. They're called the malleus, the incus, and the stapes, or more commonly known as the hammer, the anvil, and the stirrup. And if you ever have a chance to really look at all dimensions of those bones in a diagram, you'll understand why they're called the hammer, the anvil, and the stirrup. And these bones, just like most bones and joints, these bones can become brittle and develop arthritis. And just like other joints, they can be repaired. Depending on the level of the damage, they can be repaired. So they take the vibration that is received by the tympanic membrane or the eardrum, and the vibration of that causes it to vibrate against the cochlea, and that's what actually generates the sound that is transferred to the brain and what you actually hear and what you translate to be words. And then here on this diagram, this is where you see the cochlea, and it's about the size of a penny. That's why that's there. It's about the size of a penny. And that's where all the sound happens, and the hairs exist that unfortunately can be deadened or eventually, killed if they're exposed to too much noise, especially occupational noise. So this is the part that's very critical. This is the part that gets damaged. And unfortunately, unlike other bones or joints in the body, this can't be repaired. If there is such a thing as temporary hearing loss from a loud concert or fireworks, and then you wake up the next day and all of a sudden you can hear a little bit better. So that is temporary. But once it reaches a point of severe damage, then it cannot be repaired, and you have to resort to alternative measures of replacing it. The pictures you see here, just a real quick funny story. The picture down at the bottom next to the mouse, that's actually what the hairs in a mouse's hearing area looks like. So you see it's completely different. And I always tell people, if you have a hamster, you have a mouse, or you have something like that you talk to and you're loving to it because it's your pet, I just let you know they can't understand a word you're saying because their hearing is completely different. The picture up there by the little cat with the sunglasses, that's compared to the picture at the top. That's what their inner part of their hearing ear looks like, and it's actually very similar. So unlike the mouse, the cat can understand what you're saying. But as most of you know, if you have cats, they just choose not to listen anyway. So again, why? Why do we care? Well, we care because, workplace noise exposure is found throughout many industries, manufacturing, mining, or metal fabrication, just about anything. And construction, of course, is one of the big ones as well. And because of noise exposures in many of these workplaces, noise-induced hearing loss is one of the most common injuries in work and one of the most common claims for the Department of Labor year in and year out. So noise is everywhere, and we need to be cautious and really think about measuring it so we can determine whether it's truly noise or whether it's just sound. Workplace injuries are usually noticeable. So if you cut your arm, or if something happens, something falls on your foot, you can see it, you can feel it, there's pain there. And so, that's something that can be addressed instantaneously. The problem with hearing is there's normally no blood, there's seldomly any pain, and it happens slowly over time. So we have to monitor it now continuously so that you don't find out 15, 20 years from now that you have a hearing loss that can't be repaired. The goal of most hearing conservationists is that, not only when you go home at night that you have better quality of life, but when you finally reach that pinnacle and that ability to retire, that you have very, very limited, if any, hearing loss as well, so that you can enjoy that retirement that you've worked so hard for. So people who hear normally often dismiss hearing loss as a minor inconvenience and assume that living with hearing loss is no big deal. Sadly, it's often not until it's permanent that you realize how serious it is. Hearing loss problems create, obviously, communication issues and entertainment, whether it be enjoyment of sound in concerts, or even, I have a small amount of hearing loss, and like some of you maybe, I don't even notice that there's a problem until I'm in an area with a lot of background noise. And when I'm in an area with a lot of background noise, it is very stressful because I really want to hear the conversation that's taking place. And sometimes I just have to give in, lean back, and forget it, and you do feel a little bit isolated. And again, mine is very minute as far as my hearing loss, but it's enough that it's frustrating to me. So I can only imagine what it's like when you have a significant amount of hearing loss and have challenges hearing in the workplace and trying to communicate. So it does challenge relationships, whether it be at work or at home or with your family. It's a big challenge. So that's another reason why we measure and we try to make sure and protect that hearing. It also affects your job. You know, your job is affected by how you communicate with others. And if you can't communicate with others, it creates some danger, and it creates a situation where people might have to limit what you can do in the workplace because they're fearful of what might happen to you, or the fact that you may just not be able to do your job, so they have to find someone else. So it does hinder your job completion. So this is something that's strictly monetary, but it is something that you have to consider. One of the reasons we always think about hearing is it's very expensive. When you lose your hearing, it's very expensive, whether it be the cost of hearing aids that fortunately, as you might see commercials on TV, they have come pretty far down in pricing. So let's say you have probably a range of anything from $350 up to as much as $7,000 or $8,000 for a pair of hearing aids and other assisted devices. Then you have the hearing healthcare, you know, trying to go to the doctor and figure out if there's anything you can do about your hearing, or adjusting to a different style of hearing aid device, or pain that you might be having in your ear due to tinnitus, or some people say tinnitus, which is a ringing in the ears. All of this becomes very expensive and a challenge and frustration. And again, to remember, there isn't a cure for, you know, permanent hearing loss. All you're trying to do is make it as good as you can. And the truth of the matter is, hearing aids do not replace normal hearing. If you speak to anyone that has hearing aids, it's a blessing that you can use them to regain some of that hearing, but it is not a replacement. It does not give you the same effect, and it is a challenge always, not only in the sound of them, but the batteries or the charging or adjusting it up and adjusting it down. So yet another reason why we're always looking to monitor and watch for occupational hearing issues. So finally, the real why is hearing loss prevention is important because federal and local regulations and standards prohibit employers from exposing people to excessive workplace noise. And this is something we push, and most all of you have for some reason been introduced to noise dosimeters, sound level meters, or in some way, shape, or fashion. So obviously you're somewhat knowledgeable on this. So there are limits as to how loud workplace sounds can be, and these are measured in decibels, and we'll talk about that in a moment in case some of you don't know what decibels are, and how long in the amount of hours that workers can be exposed to these sounds of a certain level. So depending on the regulation, depending on the environment, these limits can be thought of in the measures of maximum allowable dose, quote unquote dose, D-O-S-E, just like with medications, you have a dose, which is the most you can take. In noise, think about dose as the most you can be exposed to. And there's noise for a specific number of hours and a work shift, or even a full day. So depending on the agency, noise exposure limits may be referred to as permissible exposure limits, or PELs, which you've probably all heard of in some form. Exposure limit values, or ELVs, or even threshold limit values, TLVs. So there is an action level which companies have to take action with a hearing protection program and make options available for people to be able to hear. And that could come in the form of, you know, earmuffs or plugs or any kind of hearing protection. And so we're going to take a real quick look at some of that a little bit later. But even when engineering and administrative controls are put into place, noise levels may still exceed the exposure limits set by companies and regulatory agencies. Likewise, engineering controls are not always feasible and cost effective. So as a result, most companies depend on hearing protection. Oddly enough, most of us are probably most exposed to hearing protection like earplugs and muffs, but that really is the last resort. We would rather take administrative controls or engineering controls to get rid of the sound or take the person away from the sound if at all possible. But, you know, the last resort is to make sure that they're wearing hearing protection to bring that sound or noise down below the action limit. And I know, again, I apologize, I'm covering some of this very quickly, but I want to make sure we get through all of it and give you a chance to ask questions at the end. So a lot of you have heard of the NRR, noise reduction rating. This is tough because the noise reduction rating is done in a controlled environment, basically in a lab where it's conducted. So I think they've done the best they can to give a noise reduction rating, but because there are so many variables in it, that noise reduction rating has to be altered, and we're going to talk about that in a moment if you haven't already heard of that. But on every set of earmuffs or earplugs, there has to be a noise reduction recorded on the label. And like I said, this is kind of done in a lab in perfect conditions to get the highest level of noise reduction rating that you can. Well, there's issues there. Number one, in a lab, they do it in a C weighting scale, which is not really the way the human ear hears. The human ear hears frequencies in a different way. We're gifted with the ability to filter out some of the sounds. And so some of you may have heard of the C weighting scale and the A weighting scale, and we'll talk about that in just a moment. But I want to, when you see a noise reduction rating on these plugs, obviously you cannot assume in this case that you can take 29 decibels off of the noise survey levels that you see in your studies. So what they have done is they've taken a formula, and you take the hearing protection rating and you subtract 7 dB from that. So in that case, you had 29 dB, you subtract 7 dB, so now you're at 22 dB. And that really is to make the conversion between C-weighted scale and to the A-weighted scale. And then you take that number, that 22, and you divide it by 2, or you cut it in half. So now you're down to 11 decibels is the actual adjustment that you can make for that particular product that showed a 29 decibel NRR. So again, you take the NRR, subtract 7, and then divide it by 2, and that gives you that variable. And you say, well, why would you divide it by 2? That's a huge number. There's human error involved. There's different anatomies of the ear involved. Some of you may or may not know one ear canal may be larger than the other. Your ear canal may be smaller than someone else's. So even though you have the best plug for the application, it may not fit you exactly the same way it fits someone else. And you may not know that even though it fits you in your left ear, it's a little bit too small in your right ear. So a lot of that's taken into consideration. And I don't want to get into an advertisement for hearing fit test machines, but if you haven't looked into it, if you work for a large company, that's something to consider, because they do a very good job of identifying whether somebody has an ear canal that's too large or too small, and it will recognize that even though it's a great earplug, it may not fit them well. Then it's hard to do that with any other way. And if you're not familiar with hearing fit test machines, they basically introduce a sound to your ear while measuring it from inside the ear canal as well, and they can truly determine how much noise is getting through that plug. They're pretty expensive, and there's some limitations to them as well. There's 2 or 3 different manufacturers, but again, something to look into if you're having problems getting people to understand the importance of properly wearing their hearing protection. All right, key elements for hearing conservation program. The hazard identification, measuring sound or noise, and we're going to talk about that. Control methods of engineering controls, which means getting rid of the problem, whether you encapsulate it in some kind of noise dampening materials or you move the machine somewhere else. Administrative controls would be something like limiting the amount of time that somebody can work in the area, and then they move to a less loud area. Then you have hearing protection devices that we've talked about. Audiometric testing you have to do if you have a hearing protection program required because of your occupational noise. You have to do audiometric testing. You have to have hazard communication and training. And then of course, one of the most important parts is the record keeping, so that you can document that you've been doing what you needed to do. First in a hearing protection or in conservation program is noise and sound monitoring. So we're going to jump into learn a little bit about the basics of sound, or is it sound or is it noise? And if any of you have children, if you've been through a 9 months of the pregnancy, one of the most glorious sounds that you can hear is the sound of a baby crying. After that period of time, all you want is that ability to hear that sound. So that at that point, it's sound, and it's a beautiful sound. Fast forward about 5 or 6 months, 4 o'clock in the morning, you're just trying to get some sleep because you were up late working, and you hear that same sound. Now, is it sound or is it noise? And most people would say now it becomes noise. So we're going to talk a little bit about sound, and because it is subjective, regulatory agencies have to do things to make it objective so that we have goals that we have to achieve. But just to give you some terms real quick, frequency, which is actually a very simple concept that we'll talk about, but frequencies are measured in hertz, which is basically cycles per second, but it's measured in hertz. The intensity or the loudness is measured in decibels. So when I talk about decibels, just know that that's the unit of measure that the intensity or the loudness or the volume, whatever you want to refer it to, is measured in decibels. Now there's also speed and wavelength for sound and waves, but we don't really worry about those when we're measuring sound for compliance purposes. But just know, you may see that at some point that somebody talks about the feet or meters per second when measuring speed, or the feet or meters for wavelength. But just keep that in mind. Sound and pressure waves. So what is sound? A good way to visualize sound is to pluck a guitar string, preferably a low bass string that vibrates slowly, so you can actually see it. If you're looking close enough, you can actually see that string vibrating. And the vibration of the string causes a sound wave. And basically the pressure wave that travels through the air, again, air is the medium for a sound wave, then that sound and energy is greatest up close. The closest you get to the string, obviously the greatest it's going to be. And then that way, as that wave travels away from the source, the energy dissipates. So that kind of just helps you kind of visualize what's happening with sound waves in the air, because you can actually see the motion of that string. So here's where we get to talk about decibels and why we measure decibels. If you didn't hear that sound, I'm going to play it again. It's a very light sound. And not only are human ears able to hear a wide variety of sound frequencies, but the range of sound levels that we can hear is from extremely quiet, like the sound of a pin drop, all the way up to sounds that are as loud as an airplane. And that's a very, very wide range. It's like 10 million times higher than the sound of a pin drop. So it becomes a challenge to measure it. So if you're looking at the threshold of hearing is about 20 pascals, all the way up to the threshold of pain, where the sound actually hurts your ear and can do damage to your ear, and you're talking about 200 million pascals. Well, it's pretty difficult to have a meter that measures up to 200 million, and you have to say to somebody that your exposure is 154,355,612. So what was done was that was converted. The threshold of hearing, which is about 20 pascals, was considered 0 decibels. And then the threshold of pain is considered about 140 decibels. So that's why most of your meters now will measure somewhere between 0 to 140 dB. Some of them have different thresholds, but most of them try to cover that specific range. Now, if you're measuring occupational noise and you're trying to do compliance monitoring, most of you may be saying, well, why does mine only do 70 to 140 dB? Well, all the regulatory agencies recognize that anything below 70 is not going to cause any damage, and so we don't really need to measure it. We're just concerned really with noise above 80 decibels. But instead of coming right up to 80 dB and starting, there's a requirement to have some range and some cushion below, which most are at 70 dB. Doubling the sound source. This is confusing for a lot of people because we're taught in math that, 5 plus 5 is 10, or 100 plus 100 is 200. And we're gonna have to say that your math teachers were wrong in this case. Doubling of noise is different. So if you're talking about OSHA, you're talking about a 5 dB exchange rate or doubling. So in that case, 100 plus 100 would be 105, but we're going to use 3 dB in this case because it's the more conservative and more protective of the user. So just think about every time noise doubles, the sound source doubles, it's approximately 3 dB. So when you see something measured and it's 100 decibels, well, let's do something more realistic. You see something that is 82 or 83 decibels and you're below the action level. Well, now all of a sudden you see something that's 86 or 87 and you say, wow, that's not that much louder. Yes, it is. It's actually twice as loud. So you have to pay close attention to that because it makes a big difference. And in the reverse of that is if you can reduce a sound or a noise in an area by 3 to 5 dB, you've accomplished a lot. You've cut it in half as far as exposure. And so the more you can do that, you know, these little steps make a big, big difference. And it could be distance away from the machine. It could be some kind of as I mentioned earlier, some kind of enclosure to reduce that sound. So it's very important to keep that in mind, that it makes a big difference. So loudness and sound pressure level, intensity and loudness, just to kind of rehash, is measured in decibels. 1/10 of a bell is basically what that is, and that's all the decibel kind of comes on the terms of Alexander Graham Bell, to be precise. 1 decibel is barely audible. 3 decibels is clearly audible, and as I stated, is basically double. And the sound energy doubles at 3. Loudness doubles at approximately 10, or it's perceived to be about 10 to the human ear. That's when we notice that it's got significantly louder. Frequency is measured in cycles per second, or it's expressed in hertz. And I'll show you a little bit different what we're talking about in hertz. So the first sound that I'm going to play for you is 250 cycles per second, or hertz. And I hope you can hear that. And then the second one is at 1,000 cycles per second, or 1,000 hertz. Now, oddly enough, the loudness of those is the same, but the 1,000 hertz sounds like it's a lot louder, and that's just simply because of the frequency. Sound energy, something to remember, is time and distance make a big difference. It's important to remember that you know, if you can drop back and double the amount of space between the source and where the person is, you can reduce that sound or that noise by 6 decibels. So distance is very, very important, and sometimes it can be something that simple in the reduction of your noise exposure to an employee is simply the distance. So here is I'm going to skip this and go to, because I'm running a little short on time. I want to go to frequency and make sure that I explain this real quick. This is what we're talking about in cycles per second. You know, just from the time it starts on the left-hand side to the time it goes up, back down, and then returns, that is basically a cycle. And so that is when we talk about frequency, how many times does it do that in a second? So just keep that in mind. Frequency is not as complicated as you might think. It's just the number of times that sound wave repeats itself in a second. I think I have another slide that probably illustrates that a little bit differently. There we go. This is the one I was looking for. So you can see the long curve that only does it one time during this 1 second duration. That is 1 hertz. They're in the same, basically the volume of these two curves is the same, but it does it 10 times. So that's 10 hertz. The 1 hertz would be a much lower bass sound versus the higher the frequency, the higher the pitch that it sounds like to you and I. So a male voice is usually prevalent at about 2,000 cycles per second, and the female voice is normally at about 2,500 to 3,000 cycles per second. I'm going to skip some of these as well because I was just have some, you can see again, there's just an illustration of the different frequencies in a piano. So here's something important, the frequency weighting. The human ear is capable of responding to frequency ranging from about 20 hertz to about 20,000 hertz. And the ear is less efficient at the high and low frequencies, and that's where you lose some of your hearing over time. And that's why it's harder to hear people with background noise, because there's so much of a roar in the background that their voice can be pretty low and be difficult to hear, but it can also be pretty high and difficult to hear. In the range of 500 hertz to 4,000 hertz, a normal human ear is very, very sensitive. So keep that in mind when noises and sounds bother you. Here's an example of the A weighting and C weighting that I talked about. And this diagram is a little bit difficult to understand because it starts with a 0, not necessarily at 0 decibels. That's the point at which the two curves are similar. And then you'll see as the frequency gets higher, the A weighted scale hears a little bit less and then climbs to a certain point. So there's a little bit of automatic and natural filtering in there, and that's why it's important when we measure occupational noise, it's measured in a dBA, so decibels in an A weighted scale. I'm going to bypass some of this on octave bands again in haste of time to make sure that I don't run out of time to do some of the training, but I do want to give some of the terms that we talked about and make sure and cover. So I'm going to skip forward just a little bit, and I apologize. All right. Oh, shoot. Sorry, I missed them. So time-weighted average and dose are very important. And the problem with time-weighted average is that time-weighted average actually isn't a valid number until 8 hours. So we get calls all the time. Well, how do I know what the noise level is if I have to wait till 8 hours? Well, that's why you'll see on most dosimeters and most sound level meters, there's the availability of L average or even possibly a P TWA or projected TWA. And that's, even though noise is not linear, the L average or the level average is what that stands for, is the best way of measuring the exposure up until 8 hours. And at 8 hours, those two values will be exactly the same. So L average and TWA become exactly the same number at 8 hours. And if you have a meter that is reading PTWA or projected TWA, it is L average. It's just some people wanted to see it as a projected TWA. So that's very important. So let me see if I can jump forward a little bit through some of these. This is important to, if you ask most people how often you must measure sound or get a noise survey, a lot of people will tell you annually, and that's not the case. It really comes down to when there's been a change, when there's been a change in the person's hearing due to a audiogram, or when there's been a change in equipment in the facility. That has to be, whenever there has been a change in production, process controls, or increased noise exposures. So don't get hung up on just doing it annually. That's probably a bare minimum, but you need to also do it whenever there's been a change. So one of the things that's very critical and difficult to do is keep a positive attitude with these sort of things, and keep people positive that you're doing this for the right reasons, because hearing protection takes a lot of time and a lot of money. So it takes a positive attitude by the management and the people involved. So some of the critical terminology, I've already talked about level average. So if you have any questions on that, the best way, and this isn't the proper term to use for it, but the best way I tell people is that is the closest you can get to a good average up until you reach that TWA at 8 hours. Again, noise is not linear, so it's not a true average. That's why we call it level average. Equivalent level, this is the LEQ. It's the same as a L average, but it's assuming 3 dB exchange rate and basically no threshold. So when you're talking about ACGIH or maybe NIOSH, you'll see LEQ used. If you're doing OSHA or MSHA, you'll see L average. Time weighted average is just a level average with an assumed fixed sample period of 8 hours measured in decibels. And then dose, of course, the reason we call them dosimeters is because of the dose. And so it's allowable daily exposure value, and a maximum allowable exposure is equal to 100% dose. And what OSHA says is 100% dose, which means the most you can be exposed to is 90 decibels for 8 hours. That is 100% dose. So going back to what we talked about earlier with noise doubling or noise halving or cutting it in half, if you had 85 decibel exposure for 8 hours, even though that doesn't seem like a big difference, that is 50% dose. So that's a huge reduction. And projected dose is basically a what if. It's a dose calculation that assumes the same exposure will continue as it is for 8 hours, which very rarely happens, but that's the best you can do with calculating, projected dose. Maximum level and peak, people get confused a lot about these two. Maximum level is the highest weighted slow level measured during the sample period. So it takes into consideration the weighted, average, and slow setting, slow response, whereas peak is the highest unweighted fast response throughout the area. And then minimum, most people don't normally care about minimum, because if we could stay at the minimum, we wouldn't have to worry about noise monitoring. All right, criterion. If exposed to the sound pressure level on an average for 8 hours, it would result in the maximum allowable exposure. So a criterion is normally 90 dB criterion level, because if you were exposed to that over 8 hours, it would result in the maximum exposure. And then threshold, for OSHA and MSHA purposes, these are set at 80 dB for hearing conservation, and then 90 dB for the PEL. And again, I apologize to go through these things quickly, but the hearing conservation is 80 dB just to determine that someone needs to be in hearing conservation program, and then 90 dB for the PEL basically determines when you have to engineer the sound out or resort to other methods of hearing conservation. Exchange rate we talked about already. So I'm going to jump into noise dosimeters. It is the first step in a good hearing conservation program. So I'm going to jump into noise dosimeters quickly and see if we can get some basic training so that we can get to some questions. So you have to consider temperature, humidity, atmospheric pressure, wind, radio frequency interference, and magnetic interference when you're talking about noise dosimeters. Those are things that you have to consider. Fortunately for you, most instruments today have good radio frequency interference or magnetic interference. But temperature and humidity still need to be considered when you're calibrating the device and where you're using the device. And of course, wind. Wind can create noise on the windscreen that is kind of false noise and shouldn't really be calculated. Check the battery, make sure you calibrate the device, inform the worker of what you're doing so that they're not concerned that you're recording them. You're not recording their voice, you're just recording the sound exposure. Place the unit and the microphone in the proper place, and then kind of leave it alone and let the normal work tasks take place. Then make sure and come back and check it periodically and observe that they're using it the right way, that they're not sitting it somewhere on the side and not using it. So I'm going to show you very quickly as far as where to place the unit.
Hello, my name is Andy Bragg. I am a technical sales representative with SKC. I'm going to demonstrate the ideal or recommended location for mounting the SKC NoiseChek noise dosimeter.
And again, in haste of time, I'm going to tell you real quick. Basically what this video says is you want to place it on kind of the peak of the person's shoulder so that it's up as close to the ear as it can be. As close to the ear as it can be. And what you want to do before you clip it in is have the person turn their head to the side that you're putting it on to make sure that their chin doesn't rub up against the microphone, creating, again, some noise, some false noise. So once they've turned it to the side and make sure that they're not touching the microphone, then you can clip it into place. depending on where the loudest noise is coming from determines which side you want to put it on. So if the most noise is coming from the right, put it on the right shoulder. If the loudest noise is coming from directly in front of them, what I always recommend is, do it this time on the right shoulder, do it the next time on the left shoulder, and get a good representative sample from both sides. But always want to be as protective of the user as possible, so put it where the loudest noise is closest. These are the things that you want to make sure that you record. Unfortunately, almost all dosimeters today record that information for you. So I'm going to jump into some quick training aspects of the NoiseChek, just so you can see it. Now, most of you have probably figured all this out, but it was designed to make it really easy using the red and the green buttons. Obviously, red means stop, no, decline, whereas the green means yes or select. And then you have the next and the previous so that you can view the information on the unit. To turn the unit on, you just press the green button until the home screen comes up. And if you've used a NoiseChek before, one of the values is you've always got a confirmation screen. So once you've turned it on, everything after that is going to give you a confirmation screen. For example, if you go to turn the unit off, you press the red button and you'll get a confirmation screen confirming that you want to turn it off. If you do, you press the green button to turn it off. So if you want to view the parameters, you just press the next button to go through the cycle, and you can view all the information, all the internal dosimeters. And what I mean by that is there's 4 internal dosimeters that you can have at different settings. You can have it only activated to 1 dosimeter, or you can have 2, 3, or all 4. But you can always cycle through that information, whether the unit is running or whether you're in the history mode. Calibration. This is one of the greatest things in noise dosimetry is how easy calibration is to do today. You basically just assure the unit is not in the run mode, can't be storing information. It won't allow you to calibrate it if it's running. You remove the windscreen, and then you turn the calibrator on and make sure it's set for 114 dB at 1000 Hertz. And then you just put it on to the unit. Again, you have to take the windscreen off and slide it down all the way on, and it performs a calibration. It will automatically recognize the 114 dB at 1000 Hertz, and then it will take 5-second count to actually allow you to abort if you want to. After that 5 seconds, the calibration will automatically begin and will either pass or fail. If it passes, the screen will show, passed, and then it'll give you 2 readings. I hope you can see that in that slide. There's a before and there's an after, and then it shows you how much is adjusted. And that before number is what it read before the calibration was performed. So that number serves as your post-calibration if you just finished conducting a survey. And then you have the after number, which is what it's adjusted to, 114 dB, and that can serve as your pre-calibration for your next session. If it fails, I would recommend that you try it again. It could have just been that you didn't have the calibrator all the way on it in time, so I would try again. But if you try again and it fails, then you may need to contact the manufacturer and see about sending it back, or contact, in this case, RAECO, and see what their process is for a dosimeter that doesn't pass. I'm going to skip that calibration video. I've already explained the before and the after, but make sure you always, always, always do a pre-calibration and a post-calibration. We have so many times that people forget to do that post-calibration, and if there's a litigation at all, you need that post-calibration information to stand up in court. So always remember, when you're done, the last thing you do is perform a post-calibration. And it's going to not only show here, it's going to show on your data when you download it, and you can also see that information on the app. So again, basic operation, I already talked about turning the unit on. If you get the confirmation screen, if you want to run and record, you press and hold the green button until you get the confirmation screen. And it just says, do you want to start now? And what we've done here is we put the last calibration information on here. So if you forgot to perform a calibration, you'll see right there that you forgot. You can go back and perform the calibration and then start this process over again. If you're ready, you press the green button and the run will start. And you'll immediately get all the information. If you notice the screen changed and it's telling you up at the top that this is the OSHA hearing conservation parameters, and you're seeing the accumulated data on the screen. You can use the next or the previous button, the right or the left button, to see the different dosimeters, and it will cycle through whatever you have set in those parameters. You can also have it set to where you can view octave bands. Not very many people do this with dosimeters, but just know that it's there in case you ever wanted to measure octaves. And it's an advantage because it can help you determine the best PPE selection. It can also help you with engineering controls, and it can also kind of help you determine the noise source, what the frequency is being produced by. Just keep in mind, it's not really designed to do an overall octave band survey, because you're only hearing frequency measurements above 70 dB. In most cases where you're doing a true sound survey with a sound level meter for engineering purposes, people want to hear everything, not just noise above 70 dB. So keep that in mind. To pause the run, you just press and hold the green button until the confirmation screen appears. You press the green button to accept it, or you can press the red button if you don't want to accept it. If you want to resume the run, you can press and hold the green button again and then select yes. So the advantage of a pause, if you've never used that before, being able to pause something means that you don't have two separate sessions. You have the ability to put two different times, whether it's before lunch and after lunch or whatever the case may be, they will be together in one study. And that's very helpful. But again, we always have a confirmation screen that's questions whether you're sure you want to resume the study. And then you would just decide whether you did or you didn't and press the green and the red. You almost never have to worry about doing something wrong because it's always going to question you on the screen. Now, to stop the run, at the end of the work period, you press and hold the red button until the confirmation screen appears, and then you press the green button to accept it, and that means that you have stopped the run. Once you stop the run, you're automatically in the history mode, and now you can view everything that you've collected in that run by using the left and right arrows on the unit. Now, what's nice is you can press the history button and you can actually see all the studies that you have done in that dosimeter before as well. All that history is stored in the dosimeter. Even after you download it, it will still be in the dosimeter. So here's the history I was talking about. You can cycle through something you did several days ago, several weeks ago. As long as you didn't delete it on the computer, it will still be here for viewing. So we put a unique feature on here that I don't know that many people use, but it's kind of, I call it kind of a digital clipboard. If you forgot to carry a piece of paper out and you're putting this dosimeter on somebody and you don't have anything to write on, you can press and hold the V button to record a message that's assigned to the study that you're about to take. And the white LED will flash and indicate that the message is stored. You cannot do that once the unit is put in the run mode because it doesn't want you recording the person. And that will be assigned to the data when you download it to the computer. Our software is very simple. It's designed to be very easy to set up, so you can select which parameters you want to use, which parameters you want to see in the graph, which parameters you want to see in the history. So you can select all of this in this main screen, whether you want to be the peak to be C weighted or Z weighted, whether you want the log data be 1 second or 60 second, and you can even lock out anyone from being able to use it once the unit is put in the run mode. And then you have a particular code that you can select. Then down here at the bottom, this is probably one of the most valuable tools, is that down you can determine which parameters you want, and you can even customize your own. If you select one of our presets, whether it's OSHA hearing conservation, PEL, or ACGIH, you cannot change the parameters because we don't want anyone to think they're monitoring something they're not. But we do have a custom feature where you can select custom and you can plug in some of your own parameters, whether you're doing a research study or whether you're trying to use it outside the country, you have the ability to customize those settings. Of course, we have all the graphing information, the ability to print it out and export that information as well. We also have an app that gives you the ability to monitor it remotely without having to get into the person's workspace. So you can see exactly what the dosimeter is showing. You can see it real time here. And then you can move on to the next one and view that one as well. So when you first log into the app, it's going to bring up every dosimeter that's within range. And then you can select the one that you want to monitor, but you can also see the one that's measuring the loudest at the time. You can also generate a nice report directly from the app. So you're viewing it on the app, you've stored it, you can send a report. And up here where you see SKC's name on this document, you can change that to be your company's name or whatever you want it to be, have your logo there so that it's your document. And it gives you all the measured parameters. So what you set it for in the top area, and then in the bottom area, it actually gives you the accumulated data. It also shows you when it started and stopped, and we give you a pre and post calibration information. So once you're done out in the field with that study, you can immediately send this compliance information back to yourself via text or via email. So that was that took a lot longer than I thought, and I apologize that I had to jump through that even faster, but now I wanted to open it up to any questions that anyone might have.
Appreciate it, Andy. That was a great presentation. We do have a few questions here. First one, are noise canceling headsets effective hearing protection?
They are, with a stipulation. Noise canceling, you really have to be careful on what the communication requirements are of the task. You can have noise canceling that is maybe not enough depending on the frequency or too much. But yes, I will say loosely, that really depends on the hearing conservation program. And I would say in that case, you really need to assess or consult with an industrial hygienist to make sure that they're proper for the application.
Is there a peak value that people should be focusing on? Some people see LC peak, LZ peak, and LA peak. How would they know what the difference is?
Yeah, it's a great question, because it all determines on what you have it set for, whether you have it for a C-weighted scale or a Z-weighted scale. And what most people, if you look at the regulatory guidelines, you really don't want to see any measurement above 115 decibels. Now, I think MSHA's number is a little bit different, but really 115 decibels of a peak gets into an area that where you could start causing instantaneous damage. I know these things measure up to 140, and there's situation where noise gets up that high, but as a rule, I would say at 115 decibels of a peak, there's a concern, and you need to assess what that issue is. And usually you do want it to be a C-weighted or a Z-weighted peak, because you don't want it to be filtered. You may see 115, 116 decibels of a peak, and your max reading may still only be somewhere around 89 or 90 because of the instantaneousness of the peak.
How would the octave bands help you determine the PPE selection?
There's so much technology today in hearing protection, whether it be muffs or plugs. Really, earplugs have come a very long way. And you can have an earplug that is really, really good at low frequencies and not very good at high frequencies, or vice versa. And a lot of times that's advertised that way. Even though you may think that having a hearing protection that can cancel out the most decibels possible is the best way to go, that's really not the way to go, because you may have somebody that needs the most minimum amount of hearing protection, but you've given them so much reduction that they can't hear anything. And so it's key sometimes to use the frequency capabilities to know exactly what frequency is the loudest, and then you can choose an earplug that is best for that frequency. And you'll see that posted on the box of the earplugs, the earmuffs. If they're really geared towards a specific frequency, it will state that on the packaging. So that's why most people in the past have used sound level meters, and certainly you still can. But I think over time, it's just convenient to have that capability on the dosimeter as well.
And the final question, where can we find the app? Is this on the iPhone or Android only?
Both, yes. You can, if you go to, I'm gonna have to look at my phone real fast. We have a different app for our pumps than we do for our dosimeters. So yeah, you're looking at Smart Wave DB. So if you look under SKC, and it can be on the iPhone or the Android, and you just look up SKC Smart Wave DB, and it's a free download, and then you're ready to go the next time you use a dosimeter. And there is a flashing blue light to let you know that it's communicating, that dosimeter is communicating with an app somewhere. And you can password protect that if you choose to, so that you're the only one that communicates with that dosimeter.
This has been great, Andy. I really appreciate you taking the time out of your day to give this presentation. Certainly a whole lot of great information on here. If anyone else has any other specific questions, feel free to call us at 866-RENT-EHS or 866-736-8347. You can also send an email to rentsconfirmation@raecorents.com, both rents with an S. If you need any other technical support, video training, we have a whole bunch of webinars, product demonstrations on our website under the Training Center tab. You can also view that information on our YouTube. SKC also has a bunch of great training videos as well on their YouTube channel. And if you guys have any other topics or training videos you want us to share in the future, we'd love to hear about that. Like I said before, you can send that to rentsconfirmation@raecorents.com. If there are any other questions, let us know. But at this point, we will wrap up this webinar, and I appreciate you all for attending. Thank you.
Thank you all very much.